It's easy to picture artificial intelligence as a conscious brain, silently plotting inside a corporate server room. But the reality is far less cinematic. Imagine you find a movie script detailing a conversation between a human and a robot, but halfway down the page, the paper is torn. The human's question is there, but the robot's answer is entirely missing. This is exactly the problem a large language model is built to solve. A large language model, or LLM, is a mathematical function trained on massive amounts of text to predict which word should logically come next. It looks at the words you've given it, calculates the statistical probability of every possible following word, and picks the most likely candidate to fill in the blank. There is no actual comprehension happening behind the screen. It is, at its core, a highly advanced statistics-based autocomplete engine. If this technology is essentially just guessing the next word in a sequence, we have to ask why Fortune 500 companies are suddenly handing over their most critical business operations to it. The answer lies in how we wire these engines together. Instead of relying on a single chatbot waiting for you to type a question, developers are linking dozens of these models in a closed loop, where the output of one engine automatically becomes the prompt for the next. This setup is known as an agentic framework. An agentic framework is a software architecture that allows AI models to pursue open-ended goals, write their own step-by-step plans, and execute digital tasks without requiring continuous human approval. The software stops waiting for a human to hit enter. When you stack enough of these autocomplete functions together and give them access to the internet, they stop acting like a passive tool. They become an active, tireless digital workforce. To understand how this digital labor operates, you have to look at its organizational chart. A modern AI workforce is divided into two strict roles: orchestrators and executors. At the top sits the orchestrator, often called the brain model. This is a highly capable, expensive AI designed exclusively to evaluate a large goal, break it down into smaller strategic steps, and delegate those tasks downward. Below the brain are the executors, or the muscle models. These are cheaper, highly specialized agents programmed to do one specific job, like scraping pricing data from a competitor's website, transcribing an hour-long sales call, or writing and testing a block of code based on the brain's instructions. In a traditional software program, an error halts the process until a human writes a fix. In a multi-agent loop, the executor simply hands its broken code bot to the brain. The brain reads the error log, adjusts its instructions, and sends it back to be rewritten. The system evaluates its own work and corrects its own errors entirely in the background. Businesses are no longer paying a subscription fee to generate text. They are deploying completely self-managing corporate structures that operate independently. Because these systems do not require human input, their true advantage is relentless speed. They execute complex, multi-day business operations overnight. Right now, researchers are deploying autonomous agents that run hundreds of intricate scientific experiments. The agent formulates hypotheses, runs the simulations, keeps the successful data, and discards the failures, all while its human creator is asleep. We are seeing this scale up dramatically. Recently, an architecture known as the perplexity computer was deployed. This system orchestrated 20 different AI models simultaneously to manage an $8 million advertising budget, adjusting bids and testing ad copy without a single human keystroke. In a single weekend, that exact deployment effectively replaced $225,000 worth of marketing software and manual human labor. The most powerful technology leaders on the planet are watching these results. They are actively funneling billions of dollars into building out this exact multi-agent infrastructure to bypass traditional enterprise software entirely. Artificial intelligence has transitioned from a desktop tool you query during the workday to a hyper-efficient employee that never actually clocks out. These massive technical achievements carry an immediate, highly localized threat to the human workforce. The most vulnerable positions are back-end roles. These are jobs that rely entirely on repetitive data processing, spreadsheet management, and internal reporting, with absolutely zero direct customer interaction. Recent industry projections show that 75% of these specific back-end roles are perfectly structured to be handed over to AI agents today. If a human's daily routine is faceless, predictable, and heavily repetitive, a digital employee will inevitably absorb that workload. It operates faster, costs fractions of a cent, and never asks for a salary. This displacement has created a structural shift toward the micro-multinational business model. Under this model, a single human operator with a laptop can generate the precise economic output of a 1,000-person enterprise. They do this by acting purely as a manager, directing a massive, specialized AI workforce to handle all the actual execution. Relentless veteran tech founders have already recognized this. They are leveraging this architecture to coordinate global operations from a single desk, effectively removing the traditional overhead of a large human staff. When the electronic calculator was invented, it possessed exactly zero true intelligence. Yet, it permanently eradicated the abacus because it performed the necessary math faster and with perfect reliability. The efficiency gap between a human researcher and an agentic loop is no longer a matter of work ethic. It is a matter of architecture. In an environment where a single operator can outproduce a mid-sized firm, those who build the systems generate the value, while those performing the repetitive tasks are simply part of a process being automated away.